Hi, I'm Sean. I'm a H1 maths student and I'm studying maths in college, and I'm here to help you get through your Leaving Cert maths questions, so let's get into it.
Okay, so here's our question. We're given three complex numbers, z1, z2 and z3, and we're given a nice equation here that describes the relation between them. We're told z2 is equal to 2 plus 3i and z3 is equal to 3 minus 2i. So we're asked to write z1 in the form a plus bi, where a and b are integers. Okay, so let's first of all just write down our equation and plug in z2 and z3. Okay, so now we've got this equation and we've got to try and work this into an equation with z1 on the left hand side on its own and a complex number on the right hand side in the form a plus bi. So the first step in doing this is to try and get rid of these two separate fractions and turn them into one big fraction. And to do that, we're going to have the same denominator for both fractions. So the denominator is going to have to be 2 plus 3i multiplied by 3 minus 2i. So we're going to multiply this whole fraction by 3 minus 2i to achieve that, and this whole fraction by 2 plus 3i, which is going to look like this. So now we're just going to multiply it in and try and simplify it a bit more. So there we have it, where we actually have one fraction now, which is exactly what we're looking for. And now we've just got to simplify this further so that we have just a normal complex number on the bottom line instead of having this sort of factorization that we've got going on. And our simplified fraction is going to be 5 plus I over 12 plus 5i. So for our next step, we're firstly just going to flip the fractions. We have z1 on top, and now we're going to try and get rid of this 5 plus I in the bottom. So once we get rid of this number here, we're going to have something in the form a plus bi, which is of course exactly what we're looking for. So in order to get rid of the 5 plus I, we're going to have to multiply above and below by the conjugate, which is 5 minus I. And the conjugate of any complex number is equal to a minus bi. So that's the conjugate, the way to quickly find the conjugate of any number. But the reason we're doing this is because any number multiplied by its conjugate will always be equal to a squared plus b squared in this sort of formula here. So if you have a plus bi times a minus bi, the result is just going to be a plus b squared, which is of course not complex, and we can work with that on the bottom. So after multiplying out the top line by expanding it and then making it smaller again, and also just applying this general formula to the bottom line, we're going to get the answer that z1 over 2 is equal to 65 plus 13i over 26. So now we just have to do a simple bit of manipulation on this equation, and we'll find that z1 is equal to 5 plus I. And that is, of course, in the form we wanted, which was a plus bi. So that was what we were in the question, and now that we've got it in that form, that's it for part A. And for finally writing this in the form a plus bi, we're going to get 15 marks. So now we've got to let w be a complex number, such that w to the power of n is equal to 1, w is in 1, and s is equal to the sum from 1 up to w to the n minus 1. And we've got to use the formula for the sum of the finite geometric series to write the value of s in its simplest form. So in this case, we're looking for the sum of a geometric series, and for that we need this formula here. And that is on page 12 of your log tables. So now we've simply got to sub in the values a, r, and n. So our a, in this case, is going to be the first term of our sum, which is just going to be 1. R is going to be equal to the number we multiply in each consecutive term by, which in this case, as we can see, is going to be w. And n is going to be our number of terms, which is just n. So now subbing in our values and writing an equation for s, we're going to end up with this fraction here, where we have 1 minus w to the n on the top and 1 minus w on the bottom. But if we go back to the question here, we can see that w to the n is equal to 1. So therefore, the top line cancels to 1 minus 1, and the bottom line will remain 1 minus w. But of course, you know, this fraction is just going to be equal to 0 now, because 1 minus 1 is equal to 0 on the top line. So s is actually equal to 0. So that's sort of what they want you to spot here for part B. And while it might have looked intimidating from the outset, it actually ended up being just a very simple cancellation. We didn't even have to do anything really with the sum that was really complicated at all. So I'd definitely be hoping for something like this in the exam. And for getting out part B, you're going to get 10 marks. And that's it for today's question. I hope you enjoyed the video and found it helpful. If you did and you're looking for more similar questions, there's going to be some of the links in the description, as well as other useful notes for this sort of topic, the topic of complex numbers. And I'll see you next time.